Assalamu alaikum everyone. Today we are going to conduct lecture number 29 of this online course, Microprocessors and Assembly Language. And today we are going to conduct our second lecture on control flow instruction. And we explored jump instruction in last lecture. And today we are going to see further variations that we can observe in jump instruction execution. So let's proceed to our topic. In last lecture we learned about jump instruction. Let me write the syntax or the format for the jump. Format would be jump and we have to mention operand here. So that was the format for jump command, and we saw some example. So let's do one example here so that we can recall the last lecture, and then we will be proceeding the variation in that code. Let's say we move a value al in al, let's say 02 hex. Then we move a value in bl in 04 hex. Then we add these two values, add bl comma al, so result will store in bl. 02 and 04 will get added, so that result will become 06 hex. And now we want to jump from this part of the code. Let's say we write JMP jump, and we want to jump to another section. Let's say we can use here any label, so we jump to label ABC. That will be served as a label ABC, and there will be a gap. Let's say there is a gap and there is a command ABC, and we will be writing our instruction that we want to execute after that jump instruction. So let's say whatever the result stored in the BL, we want to move it into BH. So move BH comma BL. That will be our instruction which will be executed after the jump statement. And look, this is the space, and here we can write any piece of code which will be skipped because of this jump command. Since it is an unconditional jump, it will never check for any condition. Whenever microprocessor encounters jump instruction, it will switch to the instruction whose address is given in this operand. And in this example, operand is what? Label. So this example is basically, one can explain operand is equals to a label, right? So let's say we write some piece of code which will be skipped. So for example, we can write anything. So let's say we can put up here ax 1023 hex, put move cx. I'm using any random commands 4524 hex. So okay, these are the two lines that we want to skip. So what will happen after this jump instruction, which is written at line number 8, one can see the number is 08 and the line number is 08, and the instruction is jump ABC. And after that these two instruction, move ax comma 1023 and move cx comma 4524 hex, which are written on line number 10 and 11 respectively. So these two lines will skip, and after the execution of jump instruction, this ABC label will be used to address the line, the next instruction, and that instruction is basically this one, move BH comma BL. So this is the line number 14 which will be executed after this jump instruction. So let's see, I'm just removing the spaces. Okay, and now let's press emulate button. Okay, there is no error. Okay, that is our code. I hope you can see it. First line is move al comma 02 hex, and it is written on 05 line. So let's press single step. One can see that 02 is loaded in AX as we were expecting, and line number 6 is to be executed on next, and this is move BL comma 04. So let's execute it, single step. We can see 04 is loaded in BL, and The next line which is to be executed next is 07 line, and instruction is add bl comma al. So bl and al will be get added. So let's execute this line. So result is 06, and result will be coming in bx register because bl register, because bl is our destination in this instruction. And the next line is 08 jump abc. Line number 08, and instruction is jump abc. And if we want to see the address of this instruction, you can see that this is highlighted over here, 01006. How this address is being generated? Okay, let me explain to you. You need to see this two variables or two register, CS and IP. You know that CS value is what? CS value is 0100 colon, and IP value is 006, right? So if we gonna use the formula that we learned, we will be multiplying segment base part or the CS part with 10, and we will add 006 or the offset part, then result will become 0106. So this is the address of next instruction what we see, because look, jump instruction is highlighted here, and the address which is highlighted is 01006 in green color. I hope you can see it. So that's how this next address is being generated. So let's execute this instruction. Okay, let me go back to the, so this is the line that is going to execute, line number 08, and let's see what will be happening. We press single step, and you know that it is executed, and you know this IP value earlier it was 006 0006. Now it has changed from 0006 to 000 E. So that means let me write it again. 006 was last value, and now it is changed to 000 E, right? And why it does happen? Actually, because of this jump command, and jump command is switching us to ABC level, and ABC level of this instruction. Look, this is the instruction. So when we, if we highlight it, look, its address is 0100 E. That means we need to switch to that address, and that address can be generated when CS is basically 0100 default value of CS, and what should be value of IP? What IP value should be 000E. That is why IP value is switched from 06 to 00E. And now we know that next instruction which is going to be executed will be this instruction, or this highlighted address will be used to fetch the instruction. And these two instructions, look, move AX comma 1023, and if we highlight it, look, 01008 this address, and the next instruction is move CX comma 4524 hex, and its address is 0100B. So both of these instructions and their addresses are skipped because of this jump command, and this new address is actually highlighted using the increment in IP. So this is the normal procedure that we understand it happens when one is going to use jump command. So jump command will be overloading or loading a new value or updating a new value inside IP instruction. So IP pointer or instruction pointer will actually point towards a different instruction compared to the normal routine of microprocessor code. Okay, this is what happens when normal operation of jump command, when you provide operand as label. But what could be another variation? So operand could be what it could be. It could be direct value which we want to be loaded in IP. And how that going to happen? Let's do this using an example. Okay, I'm going to use the same code. For example, move AL comma 04 hex. Maybe values are changed. I'm not regularizing the values. 02 hex. Okay, and we add them BL comma let's say BL comma AL, whatever this is a piece of code, just add an addition of two 8-bit numbers, and now we want to jump to some certain other location, and let's say IP value we want to be used, or we want to jump to a location whose IP value is what, let's say whose IP value is for example IP value is 001F, right? This is the IP value that is going to be used in IP when jump instruction is going to execute. Okay, and then we have some piece of code which will be skip, of course, move AX comma, let's say CX, move BX comma DX, and so on, whatever, and this time we don't know where this 001F will be, so let's explore it using this emulator example. So press the emulate button, everything is okay, there was no error, and remember we are exploring this operand is equal to direct. So single step 04 is loaded, everything is okay. One thing which you can notice that 04 is move AL comma 04, this is the first instruction, like given on line number 5 is executed, result is here. The next instruction is move BL comma 02, which is given on line number 6, its address is 01002. How 01002 is being generated? Using the value CS is equal to 0100 and IP 0002. So I hope this is at this stage now these things are very clear. So let's press this button again, single step 02 is loaded, this instruction was executed. The next instruction which is going to be execute is 8 BL comma AL, and it is given on line number 7. And what is its address? Its address is 01004. How this address is being generated? Again using the value of CS 0100 and the value of IP 0004. That is why 0004 is being mentioned in IP. Okay, that's okay. Now we press single step 06 is loaded. Now the next instruction is what? Jump 1F, sorry, and jump 001F is given is written on this address 01006. And what is going to happen when we execute it? It will be jumping towards 001F. What is this 001F? 001F is going to be loaded in IP. What is current value of IP? IP value is 006. So what will be the physical address which will be pointed by after this execution? That address can be calculated using the same formula. CS value is what? 0100, and IP value would be what? 001F, because it should be changed in this manner. So once we are going to resolve it, it will become 01000 plus 001F, and that would become 01001F. Okay, that should be our next address when we are going to execute this jump instruction. So let's see if it is going to happen or not. So we are pressing single step, the value is 006, and it is supposed to be changed to 001F because it is given in this instruction. So let's press single step. Look, this is actually happened. So now we were at some other code segment value, but now we have moved to this value. We don't know whatever written here, it's just dummy location right now, but if you are writing a greater program or a program which is larger in length and you want to switch to any specific value or any specific location where you want to access any instruction, so you can use this method where you are going to use the direct offset value inside this jump instruction. One thing which is noticeable and intriguing question could come in your mind, that why user will be having that address, because it is something which is given in the code segment. The question is right. Normally this situation is not available in with user, or this information is not available with user, that where that specific instruction which is in which I am interested to be executed is going to be present on what instruction or what address. So that's very much right. But if you are writing a very simple code or very simple application code which is known to programmer who is programming that application very well, so programmer knows in what location what he expects and in what location what he expects to be written, and if programmer is in debugging mode and he is resolving certain issues present in that application, so he may choose these kinds of jump instruction to check specific locations and their content. So you can say that this jump 001F or jump giving the direct address is not usually used, but it's very useful for those programmer who are in debugging mode. I hope the point is clear. Okay, in last example we have seen operand as label, we have seen operand as a direct object or direct address, and now we are going to see another important variation in which operand could be the value which is stored in the memory. And how we are going to see that memory, we are going to see we are going to observe that specific thing in this example. Okay, let's say we have a value px, okay, and px value is 0202 hex. We have a value of cx 02454 hex. Okay, I'm sorry, I wrote one thing extra, one letter extra. Okay, now what we are doing, okay, at this stage one thing which is important to note, what is our data segment value? Data segment value is equal to what? Data segment value is equal to 0100, and code segment value is 0100. You know that we are going to modify these values 0100 in data segment, because code segment and data segment both are kind of overlap in this emulator by default. So we want to just use a different segment of memory or different portion of memory for data segment and different portion of memory for code segment. So we are just going to insert a new value, and let's say how we can do it. Move x is equal to 0200 hex, and we want to switch it to ds, so ax. So now our data segment should be what? 0200. So data segment would be becoming equals to 0200, and cs is 0100. Again, why I actually did it? Because I want to use different portion or different memory locations for data segment and different memory locations for code segment. Why I'm doing it? Because this time operand will be stored. Okay, d was missing. Operand is equal to memory, so we will be trying to access a data segment location using operand. So we will be doing it. That's why I switch it to a different memory locations. Okay, I'm sorry for the noise. Okay, I think now noise is clear. Yeah, so let's say we are using jump. Okay, we will be jumping towards, let's say if we were, what we were doing, we were jumping to 001f, and this time we're gonna jump towards 002f. okay, but we will not use this direct address in jump operand. Rather, we will be using this 002f to a memory. So we will send this value first into the memory location 002f hex value. We will be sending it towards certain memory location. Okay, and then we will be using jump, and operand will be used as memory, and since memory will holding this value, so we will jumping towards 002f. So first of all, we're gonna do this step. How we are going to do this step? Let's say we are move. First of all, let's me move this value in any data register. Dx is equal to 002f hex. Okay, and now move. Let's say px is of course pointing towards certain memory of data segment. It is a based addressing mode. I hope you remember, we have covered it. If you haven't if you don't remember exactly, so please recall it using my separate lecture. So at this stage I'm not going to explain what is base addressing mode, but we are using it. So I'm going to suggest, if you don't know base addressing mode, so please go to addressing mode lectures. There are 3 separate lectures available on addressing modes, and I hope it is lecture number 3 on addressing modes, in which you can find this move bx comma base addressing mode. So move bx in memory operator, and we will be moving dx value. So whatever the value of dx value is what, 002f, it is going to move inside the location which is pointed by px register. So now we know that that memory is specifically holding now value of 002f, and now we will be switching to jump instruction, which is our original task of this lecture. So instead of using direct address in memory, in jump operand, we can actually specify that operand or that value in certain memory in advance, and after in certain debugging mode we can recall that location using simply jump, because and at this stage it becomes more practical, because or in this way it becomes more practical because it may never known to programmer what is the actual debugging location, but it may very well known to the program itself. So we can actually specify using certain registers or certain memory locations, and we can recall those values using that memory. So we will be doing it. I hope this point is clear to everyone. I'm going to explain it again in a while. Just let me comment it first, and I'm going to explain the full program again. Okay, so this is our program which will serve the purpose in which we are going to use operand as memory. So let me press the button emulate. Okay, everything is okay. Now press single step. Okay, let me show you here. Okay, that's it. In original source code, line number 7, first line is what, move bx comma 0204. Okay, so that value is bx is equal to 0204. Let's see if it is going to happen or not. And its physical address is what, physical address is 0100. How this address is being generated, because value of cs is 0100 and IP value is 00. So let's single step. So now one can see 0204 is loaded. Perfect, everything is okay, right? And IP value is 03 because it is pointing towards next instruction, which is move cx comma 2454 hex, right? And 03 and 0100, these values are used to generate this location. Let's press single step again. Okay, now ax value is what, okay, cx value is 2454, that is okay. Ax value is 0200. So why we were doing so, because we wanted to change data segment. So single step and single step, and now you can see this data segment value is changed 0200, right? And now what is the next address? We want to put that value in some data register first. So single step, look, 002f is loaded in data register dx. Okay, now we want to move into the memory location which is pointed by px register. Px is holding what, 0204, and data segment value is okay, that thing I'm going to do here. Memory location address. Okay, memory location address, and I'm going to use data segment is segment override and px register as offset part. So it will be holding 0200 colon and 0204. So if we generate a physical address, it will become 02, sorry, 020000 plus 2, sorry, 0204, and it will be equal to what? 02204 hex. Okay, that will be physical address at which we can find this value 0024 after the execution of this instruction. Let's see if it is going to happen or not. Single step. Okay, something has happened. We know that the instruction is executed. So if we want to check whether that particular location is holding the value correctly or not, so we can use this logical address. We can change this 0200 and what was it, 0204. Look, I'm going to press just enter, and now you can see this address. It is exactly this address, 02204 02204, and it is holding the value 2f, which is coming from where? Coming from this data register. So I hope this point is clear to everyone. So now this address, this memory location is holding this address 002f, right? 00 is stored in the next content, because you know that every memory location actually stores only 8-bit value, right? So 002f is being holded by these two locations. So I'm gonna go back to this location, jump. Its address is 010 because IP value is 0010. So as I'm going to execute this command, where it will move, this IP value will switch to that memory location, and that memory location is holding what? 002f. So let's see if it is going to happen or not. Look, it has actually happened. It has actually happened. 002f is loaded. So in this manner, one can actually use memory as an operand and can go everywhere in the given code segment to debug or to modify or to execute any instruction. I hope this point is clear. This is a bit complicated from last previous lectures, but since we are moving towards some advanced topics, so this could be one of the starting of those advanced topics. So I hope these points are clear to everyone. Okay, that's it from this lecture. Today we learned about what? About jump operand, and we saw three different versions of jump operand in which you can actually vary the operand of a jump instruction. So I hope all those three variations are clear in your minds, and still if you have any question, please note them down, note those questions down so that we can actually discuss in online session. Thank you so much for listening.